have here is circles touching it goes, the x-axis is a tangent to the circle x squared plus y squared plus 2gx plus 2fi plus c. Show that g squared equals c. So what we're going to do is we're going to do exactly what's on the first blue box. You're going to construct a circle, okay? And this circle, as in the description, it says the x-axis is a tangent. So you extend that circle until the x-axis is a tangent. Everybody happy with that? Now, by doing this, what you realise is that the generic expression for the centre of the circle is minus g minus f. Correct with that? You happy with that? Now, any point directly underneath this is of the variety minus g something. But we know that the y value is 0. So that makes that minus g 0. Okay? Now, therefore the radius has to be equal to what, guys? The drop in the f value. So, to give you an everyday example, okay, if I was to draw another diagram similar to this, except this time I'm going to give you the centre of the circle, okay, using real numbers, okay, so, and I'll just be a bit pedantic about this here. There you go. Now, what we're looking at here, guys, imagine I told you this is the centre of circle, 3, I don't know, 3, 2, something like that. 3, 2, right? It probably doesn't make sense, but what I'm trying to say is that if you drop that down, directly underneath that is
3,
and that makes the radius 2. No, length can't be negative, so that explains the modulus sign. It's the modulus value of minus f. So that's why the radius here, the radius value is the modulus value of minus f. Did everybody happy with that?
Yeah.
Now, using the formula g equals radius equals g squared plus f squared minus c. We now know that the radius is the modulus of minus f. Then you have g squared plus f squared minus c. Alright, square both sides. And once we square both sides, f squared equals g squared plus f squared minus c. F squares cancel. So for this specific example, g squared always equals c. And likewise, when the y-axis hits, f squared equals c. You happy with that?
Yeah, great.
And just an extension on that, when you have, in the rare case, that you have that both of them are tangents, okay, and this is a rare case, what happens is the first proof still holds true, doesn't it? Because the x-axis is still a tangent, right?
Yeah.
And the second one also holds true as well, because the y-axis is also a tangent. Therefore, g squared equals f squared equals c.
So would that be the centre was 3, 3? Would that be?
That would be like 3, 3. Yeah, you're right. The number would have to be the same. For the hit both of them, the number would have to be the same. 4, 4, 5, 5, 1, 1, a half, a half. Okay. Now, is everybody alright with that? Would you like me to do the y-axis version?
No, so you know, if it's like that, and g squared equals f squared equals c, then you have to, how do you put that?
Sorry, just let me do one more thing here. I'm going to do the y-axis equivalent of this, lads. The y-axis equivalent is this. I have a centre of a circle. This centre is 3, 4. Okay? On the same line is what point should this be then? If it's directly across, parallel to the x-axis. Sorry? 0, 4. X value changes, y value doesn't. What does that mean about the radius? 3. Likewise, minus g minus f, and if you go to the left, the radius has to be equal to the modulus of minus g. Okay? In the same way that the radius is equal to the modulus of 3. Okay? So, we then use the formula the radius equals the square root of g squared plus f squared minus c, square root it. We now know that the radius equals minus g. We're now going to square both sides in a second. So when we square both sides, we're going to get we're going to get g squared equals g squared plus f squared minus c. The g squareds cancel, and we're going to get c equals f squared. F squared equals c. Same thing. It's not that bad. That is something you could be asked, though, right? So you need to be able to do that. Okay. Now, what we're looking at next, guys, is the x-axis of a tangent of a circle at the point 5, 0. The x-axis is a tangent to the circle S at the point 5, 0. Find the point 1, the point 1, 4 is on S. Find the equation of S. Okay, so here's what we're looking at, guys. We're looking at a circle, and it has the point 5, 0 on it, and it also has what's the other part?
1, 4.
1, 4 is also on it. Okay, so what we're going to do first, we're going to use our, see this generic formula here? Yeah. And here's what we're going to do. We're going to substitute in 1, 4. Let's pick up the marks we already know from previous exercise. The marks we know is 1 squared plus 4 squared plus 2g times 1 plus 2f times 4 plus c equals 0. 2g plus 8f plus c equals minus 17. You happy with that? Yeah? Now, let's pick up more marks. We know that 5, 0 is also a point on that circle. So why don't we construct the second? Why don't we construct the second equation quite quickly? Sure, might as well. So we're going to get 5 squared plus 0 squared plus 2g times 5 plus 2f times 0 plus c equals 0. Yeah? And then we're going to get 10g plus c equals minus 25. Remember, 3 variables always requires 3 equations. Now, this is where our knowledge comes in here. You go, wait a minute. If the x-axis is a tangent, that means that g squared is equal to c. So here's what we're going to do. Straight away, I'm going to replace this c here with g squared. I'm going to get g squared plus 10g. I'm going to bring the 25 back over where it came from. Plus 25 equals 0. I'm going to get g plus 5 multiplied by g plus 5 equals 0. G equals minus 5. C therefore is minus 5 squared, which is 25. And then all you gotta do is put it into this equation here. 2 times minus 5, Connor. 2 times minus 5.
Good afternoon, sorry for class intrusion, but just
excuse me. Now, what we have next is 2 times minus 5, 8x, which we don't know. We know that c is 25, and we know that all of this equals minus 17. So therefore, what we're going to have here is we're going to have, that's minus 10. Minus 10 plus 25 is plus 15. Plus 15 going over the other side is going to turn into minus 15. 8f equals minus 32. F equals minus 4. Is everybody happy just to put the minus 4, the 25, and the g equals minus 5 back into this original equation to find the equation of the circle? Yeah. Any questions?
No.
Okay.
Actually, where's the radius in that?
So, question 7 part 3. It has a centre in the first quadrant. What does that mean, lads? What does centre in the first quadrant mean? Positive x, positive y. X and y are both tangents. The x and y axes are both tangents, like a glove. Okay? And point 36 is on x, somewhere up here. Okay? And what we're going to do is this, guys. We're going to write down, we're going to pick up our easy marks by replacing x with 3, y with 6. So we're going to get 3 squared plus 6 squared plus 2g times 3, 2f times 6 plus c equals 0. 6g plus 12f plus c equals 9 plus 36 is minus 45. And this minus 45, lads, okay? We're sorry lacking information at the moment. Find 2 equations for S.
You could say that.
Is that all what's asking me for?
Yeah.
There's one equation. And
You could say that.
the other equation would be g squared equals f squared equals c. Now let's just hold on with this for a second. This also means, guys, is that the centre of the circle is minus g minus f. And remember what we said earlier. The centre of the circle could be 1, 1, 2, 2, 3, 3. The x value, the g value equals the f value. So because we're told it's in the first quadrant only, we can just simply say that g equals f. That's the only thing we have to worry about. Now, just looking at this equation here, I think what we can do is this. I can just say 6g. I can replace f for g, 12g. I can replace c with g squared, and that with minus 45. Then I'm going to get g squared plus 18g. Okay, g squared plus 18g plus 45 equals 0. We're going to get g plus 15, g minus 3. I'll say g plus 3 equals 0. Now remember, the centre circle is minus g minus f. So to have a first quadrant centre, I was expecting a negative number, wasn't I? So g equals minus 15, g equals minus 3. F therefore is the same value, minus 15. F is also minus 3. C is the square value of both of them, which is 225 and 9. And then finally, I'm going to put them into the x squared plus y squared plus 2gx plus 2fy plus c equals 0. And what I'm going to get is x squared plus y squared, 2gx minus 30x minus 30y plus 225. Is that the answer?
Yeah.
And then the second one is x squared plus y squared minus 6x minus 6y plus 9 equals 0.